Let me invite here the moderator of our next talk. This is Alex. Alex, hi, welcome to the Java conference.
Hello, Roman. Nice to be here. Nice to see this fantastic conference. I've been to majority of talks yesterday, and I am really impressed of the level of content you're providing. So that's really fantastic. How are you doing?
Yeah. Fine, fine. You know, it's that you just need to start doing something, and after that, it's just like rolling. So yeah. So we are waiting for our next speaker. This is Vadzim Kavalkou, as far as I remember. What can you tell us about his talk? What would it be about?
Well, you know, we're moving from on-premises to containers and from containers to cloud. And it's, to be honest, quite important to understand what technology we should use in every area. Because, you know, Java was invented more than 20 years ago, and it was fantastically fine in backward compatibility. At the same time, we have a big burden of legacy, like long startup time. And of course, we have a lot of opportunities, frameworks and tools which allow us to make our Java application running better, like GraalVM. Our major frameworks like Spring Framework or Quarkus also provide us with support of all these things. And well, if Quarkus was built as cloud-native solution from the very, very beginning, it was built from scratch. Spring has a long burden of many software which were already written on it, and it's necessary to migrate bit by bit, step by step, module by module. And Vadim will tell us what we should use and in order to migrate, let's say, what should we use in order to start thinking properly about building cloud native applications, first of all, and what framework might be better for your case. And also, there is another, let's say, important aspect of the talk. Vadim highlights what's regarding performance as well, because even if your application starts quickly and works slowly, it means nothing. It is not something very, very good.
And saying that, let me invite Vadim here so he would join our discussion. Hello, Vadim. How are you?
Hi, everyone. Awesome. Thank you. How are you guys?
Good. Is this your first cup of coffee today?
This is not a coffee. It's milk with honey.
Oh, nice. Nice. Cheers. I have tea here. So cheers.
Cheers.
Yeah, Sasha, you're with us. So, Vadim, we were discussing your talk and what, how could it be useful for guys who are listening to us. Maybe you can give us some spoilers. Like, what will you share with us?
No spoilers.
Okay.
I don't like to share spoilers, and to be honest, I don't like spoilers at all. You know, it's kind of you are going for Marvel, looking at new movie, and you have some spoilers.
Okay, we got your answer. We really do hope it will be really great. So I think that saying that, we may move to the talk. Before we finally do that, guys, I may tell you the following thing. So we have three options for you how you may post a question for Vadim during his talk. So first of all is the chat here on YouTube. This is the main source where you're watching our conference. So just write your question there and we will be able to show your question on the screen also. Second option is Discord server. So on Discord server, you may find the chat inside Purple Stream Talks, which named the same as the talk of Vadim. Honey, I stress tested, blah, blah, blah. If you have three dots there, you will not see all the other part. You will see just the beginning. So this is the chat where Vadim, we'll have a look on the questions you sent to Vadim. Third option is Wear Community, where you can also enter the talk, and there you can see the chat inside the talk, and this chat will also monitor it. So we try to look in three sources. We try to collect questions from all three parts and answers if they will be there, of course. So please don't stay silent. Please participate. Please join our Discord server. A lot of fun happening there. Saying that, guys, good luck on your talk. Vadim, good luck. Alex, good luck in moderation. Guys, floor is yours.
Okay,
Yeah.
so I'll present and share my screen. Okay,
Yeah. Yes, please. Okay.
could
No.
you please
No.
tell me if you could see my screen, my presentation?
Yes. You're on air. It is visible. I think you may start.
Great. So again, hi everyone, and today I will share the results of my research. It's about the performance investigations in Spring and Quarkus, and compare the results of shrank native images with other ways of building artifacts. And as you could mention, I have the reference to the 1989 comic science fiction film Honey, I Shrunk the Kids, and the reasons of it are I shrank our artifacts to gain the benefits in storing and delivering and in other areas. And the second one is I was born in 1989 as well. So let's move forward. Let's take a look at the agenda. Um, Firstly, we'll take a look on the slide that will tell you why you should trust my results. And after that, we will cover major steps of research, compare the results of Spring Servlet Stack, Spring Reactive, Quarkus Reactive, and weigh the results of Quarkus and Spring, and think over the Docker performance problems, and gather everything together. Okay, let's move forward. Who am I? A bit about the experience, domains, technical stacks, and social networks. So, my name is Vadzim Kavalkou, and I am a chief software engineer at EPAM Systems. I have an essential and winning skills across different technical stacks. There are my modest GitHub stats and social networks, so you could find me and follow the LinkedIn, GitHub, or Instagram. Okay, let's move to the introduction. We will discuss the questions of research, predictions, and kind of presets for gathering and analyzing data. And what about the question to research? The question to research, what approach is most efficient? And we will concentrate on the next metrics. First metric is a build time. This metric affects such areas as time to market, and based on it, you could significantly increase or decrease, for instance, the release of feature or a bug fix critical, for instance. The second one is the artifact size. In software development, we are paying for storing and transferring data, and so the less your artifact is, the faster and cheaper it could be delivered or maintained. Boot up time. The minimal boot up time, in coupled with the build time and artifact size, provides us better mean time to repair, and the application could be scaled up faster, almost instantly in several cases. RPS. Pretty easy. How much requests could be handled by the system per second? And resource consumption. This is about the random access memory and CPU utilization. So taking a look on this metric, you could suggest what kind of virtual machine, for instance, in cloud you need. What about the predictions? In this research, we will compare the different ways of building the artifacts in Quarkus and Spring, and so what these frameworks are talking about themselves. Quarkus is fast in boot time, optimized for cloud, serverless, and containers, low resident set size. Spring Reactive provides potentially massive numbers of concurrent connections with fewer resources. Spring Native boot up is instant, higher performance and lower memory consumption. Looking at these quotes, I would like to predict that Quarkus in average will consume less resources and has the lowest boot up time. Also, I think that Spring Reactive will have the higher RPS, and Spring Native will try to repeat the success of Quarkus. So, trust but verify. What about the basic configuration? I have the typical MacBook Pro, and all the frameworks are in the same conditions. The LTS of JDK and the latest versions and tools or frameworks on the time of testing. What is the application for research? The application is typical transportation service with 60 per day and 112 hours of load per week in Belarus major cities. Also, we have some assumptions and constraints. I disabled all application level caches to get clear performance metrics of the server as it is. The database and application are in the same network to avoid the net lags and penalties. The average time to boot up the service will not depend on the database structure due to the fact that all database structure had been already prepared and filled with fake data. And I'm not using any database migration tools such as Flyway and Liquidbase. What about the database presets? So let's begin our journey, aka research. First of all, we will prepare the database schema. As you can see, the schema is pretty easy and small. In total, we will prefill 500,000 users transfers and 200,000 of users. We're just trying to simulate a real life case. Okay, let's try to prefill data with similar to production fields, for instance. You could follow this QR code to try to do it on your own, or just take a look on the sources. To do prefilling, I'm using a data faker library, and in common, generation is completed by Spring command liner. It's about the generation test not beginning at that moment. We just trying to generate user transfers and to generate the users. Faker helps us to enrich the data with kind of quotes, or if we will just now take a look on the user generator and funny name or phone number, first name, last name, and etc. etc. After that, we already have a prefilled database. We are moving to creation a custom Docker image. On this multi-stage build, you could find that I used Postgres 40 as the base image. After running the script, we are getting our custom Docker image with size of database 153 megabytes, and the dump is 131, and common image is 160 megabytes. Why common? Due to the fact that every new artifact will use the same data set independently. Every solution is on the same condition. Use cases. To simulate the behavior of real users, we will use this scenario. The same way as we are choosing the country, origin, destination, date for travel. For sure, you could see your transfers, your profile. You could update your profile, or even transfers cancel or update as well. And I believe you are familiar with several similar transfer providers. And I used the first API first approach, where first I generated the API documentation and used the code gen to prepare code base for different frameworks. It's very useful when you are going to work with a cross-tech environment. You could open the Swagger editor and add your API documentation just to take a look at it and to get the data. For instance, you could take take a look at the points of a country and the payloads for updating or signing transfers, kind of like this. So at first, you could try yourself to preset the Kotlin using this QR code. But right now I will describe you a bit, provide some information regarding the Gatling and performance tests. This is the second benefit of the API-first approach, and when all the teams could work in parallel. An example, when you develop your backend part, the front-end developer could develop the UI, and performance test engineer writes the performance test. So based on the API documentation I've created, I would like to create the Gatling scenario. And as you can see, I'm using the latest version of Gatling with presetted JVM arcs, and we can set up the logback or typical Gatling configurations such as caching or encoding or SSL, connection timeouts, whatever you want. So the simulation, we are going to create 200 users. We are working with 200,000 users, and we prepare a feeder for it, and we could use different warm-up URLs or kind of presets of your HTTP protocol, and then we are going to create this scenario. So right now you can see that I am using the API and endpoint to find the countries, and randomly I'm choosing the country ID that I will use later for different endpoints, such as searching the cities or origins or booking any transfers, etc., etc. And moreover, you could set up your ramp, users per second, and duration of your performance test, depending what kind of test you are going to have. Okay, let's begin to test the frameworks. This servlet stack will be the first. And the typical Spring MVC performs as blocking thread per request model. To be honest, this approach is not optimal nowadays, but there are a lot of legacy systems we are supporting, and we have to know what to do in different cases. What about the Spring Native? Spring Native compared to the JVM just can enable cheaper and more sustainable hosting for many types of workloads and microservices, function workloads well suited to containers and Kubernetes. Using native image provides key advantages such as instant startup, instant peak performance, and reduced memory consumption. There are also drawbacks and trade-offs that the Grail VM native project expect to improve on over time. Building a native image is a heavy process that is slower than a regular application. A native image has fewer runtime optimizations after warm-up. Finally, it's less mature than the JVM with some different behaviors. The key difference between a regular JVM and this native image platform are aesthetic analysis of your application from the main entry point is performed at build time. The unused parts are removed at build time. Configuration is required for reflection, resources, and dynamic proxies. Class path is fixed at build time. No class lazy loading. And some code will run at build time. Okay, now let's take a look at the numbers of a Spring Servlet stack, non-native stack. If you would like to have the faster boot up, I would recommend you to use the Undertow. But if you are going to have the higher RPS and in non-Docker world, I would suggest you to take a look on Jetty or Tomcat, and Tomcat provides the response time a bit lower rather than Jetty and Undertow. What about the native results for Spring Servlet stack? As I said already about the build time, the native build tools provides us the build time increased in 41 times. But you will get almost instant boot up and higher RPS, lower response time, and higher saturation point with less memory consumption. But you can find that artifact size a bit bigger. When you are using a build pack, you could create your Docker image, and the size of this image will be less than the typical Java in Docker solution. So depending on what are you going to choose, you could shrink your image, for instance, using a build pack, or blow it up if you are using native build tools. Let's compare Docker images. Nowadays, we are paying for everything, for storing, for transferring data, and the less your data is more comfortable and cost efficient. So the total image size for native solution in 2 times less and lower. Spring Reactive stack. Spring Reactive is based on the Spring Web Flux, and it's about the non-blocking, and as I said before, provides us the solutions that helps handle massive number of concurrent connections. And in comparing with servlet stack, yes, it's a non-blocking web framework. When the Spring MVC is synchronous blocking I/O. But when you will decide to rewrite your servlet stack on the reactive stack, you will pay a lot of time and, I believe, money to rewrite, because of this is absolutely other way of developing the application, the other approach. Let's take a look at the numbers of the Spring Reactive stack under our stress test. You can find the build time for the typical jar lower, and it's about 3 seconds in comparing with jar and Docker, 40 seconds almost. And the size of jar in Docker pretty similar to the previous one when we've used the Spring servlet stack. But right now, we have the RPS higher almost in 2 times just when we rewrote our application from the servlet stack to the reactive stack. We get the higher saturation point and the lower response time. Okay, what about the native solution? Again, we have a build time. It had been increased in almost 60 times, but we get almost instant boot up. 100 milliseconds, amazing. Less memory consumption, but a bit higher artifact size. When we are using a build pack, it's about creating the Docker image. We are getting the size of almost 100 megabytes, and it's pretty less in comparing with previous one solution. And we get the lower boot up time, lower random access memory, and lower response time. We are paying for it with the saturation point and the RPS. So depending what you're choosing, again, you could shrink your image or blow it up. Up to you what you're going to do. Let's imagine, let's compare the images. And for the non-native approach, we get the total size almost 300 megabytes and almost 100 megabytes for the native approach. As I said, nowadays we are paying for everything, for storing, transferring, etc. The lower data you have, less you're paying. What about the Quarkus? Just a brief overview. Quarkus is about the developer join and about the Kubernetes native. It's about the cloud solutions and etc. Different extensions, libraries, and let's take a look on it. As I said, Quarkus is about the cloud serverless and containerized environments. But Spring have the 3.0 version where now Spring is not about the enterprise application. Spring is opened now for the cloud and serverless applications and approaches. Let's take a look at the numbers. To be honest, Quarkus provides for about 50 or even 70 different approaches to build your application. Just up to you what to choose. Now, we can compare the numbers of the typical jar with a boot up time lower than 2 seconds. In comparison with Spring, we get higher than 3 seconds boot up time. And the building time for our in-Docker solutions a bit less. So in case if you are going to have the higher RPS using Quarkus, I would suggest you to use the Uber jar. In case if you are going to have the less artifact size, the same. When you are working in a Docker world, I would suggest you to use JIB-built, but Distillers is an experimental one nowadays in Quarkus. Let's compare the UBI and Distillers images. UBI size almost 400 megabytes for one instance. Too much, to my mind. To be honest, Distillers provides us 250 megabytes, and this is too much for me as well. Let's take a look on the native results. And as you can see, the Distillers base image using in a native world has for about 70 megabytes of artifact size, pretty less, with less boot up time, with higher RPS, lower response time, and higher saturation point and less memory consumption. But we are paying for it with our build time. So it depends on what you're choosing. Depending on what you're choosing, you could shrank your image in case if you are using, for instance, a Distillers base image or manually minimal base image or micro base image. When you are using native executable, your artifact size will increase. So let's compare manually created micro base image and manually Distillers base image. They are pretty similar for about 17 megabytes. To my mind, this is really great numbers to work to store and transfer this from one region, for instance, to the other one region. Less data, less bills. Okay, Quarkus and Spring. Now we have all our metrics, and we could compare them. Comparing the jar results, it depends on if you would like to have the lowest build time and the higher RPS using the jar. I would suggest you to take a look on the Spring Reactive. In case if you are going to have the lower artifact size, boot up time, and you will pay. You could pay for it with RPS a bit. You could choose the Quarkus. Let's compare the native executable results. Again, if you would like to have the higher RPS, and in this case a lower boot up time, I will suggest you to take a look on Spring Reactive. In case if you are going to have the lower less artifact size, I will recommend you to take Quarkus. Let's compare jar in Docker results. Again, Spring Reactive handles much more requests. And if the RPS for you is a significant metric, you would like to bring the Spring Reactive into the world. In other cases, you could choose the Quarkus, and the Quarkus will provide you the lower build time and less artifact size and lower boot up time, but it will consume a bit more random access memory. And now native and Docker results. You can find that the boot up plot has significant difference between the Spring Web and Spring Reactive and Quarkus for a boot up. Again, Quarkus size a bit less, a build time again lower, random access memory pretty similar with the Spring Reactive. So in case you are going to have the higher RPS and you could pay for it with your build time, your artifact size, I will suggest you to take a look on the Spring Reactive. In other cases, the Quarkus. What about the bonus? As I said, I will provide you some information regarding the Docker performance problems. And as you can see, our previous results for in-Docker solution had been not so efficient. The RPS was lower and memory consumption was higher, and Docker is using one mechanism named seccomp, and this issue had not been fixed yet. This issue, there is no this issue in Podman and Kubernetes, but you could disable it when you are going to run your Docker image, and for sure using the volumes to create the storage directory on the host machine. I've tuned my Docker images, and we now can compare the results. For tuned native distroless image, we get the higher RPS, lower response time, and higher saturation point. Okay, let's sum up. As I've said at the very beginning, we should trust but verify. And the Quarkus says amazingly fast boot time, incredibly low RSS memory, not just heap size. And yep, it had been tested. That's true. Spring Reactive says that it could handle potentially massive numbers of concurrent connections and increase your performance, handle more requests. Tested, and that's true as well. What about the Spring Native? Using native image provides key advantages such as instant startup. Yep, that's true. Instant peak performance. To be honest, I'm not agree with it. And reduced memory consumption. Not at all, in some cases. So, rejected. Now, I would like to share with you my flow. Let's try to gather everything together. I'm sorry. If you have micro nano services and the boot up time is significant for you, and you are using containers, I would recommend you to use a Quarkus native based on micro-base image or distroless. But remember that distroless is an experimental at the moment. If your if the boot up time is significant and you are not working with the containers, I would recommend you to use Spring Reactive with native build tools, just native executable. In cases when the boot up time is not significant for you and you are working with containers, please take a look on the Spring Reactive with JIB and distroless. In other case, if you are not working with containers and the boot up time is not about your major metric to be, just bring the Spring Reactive into production. In other cases, it could depends on the competency of your team. Thank you very much for watching my presentation, and I'm really happy to share my knowledges and my researches with you. Thank you. You could follow this QR code to find the sources and try to do it on your own. Alexander?
It seems I'm on mute as ordinary. So thank you very much for your fantastic talk. Well, I don't see many questions in the chat, but still I have a question from my side to ask. So as far as I can see, you've written the same application using multiple frameworks. What was the framework which brings you the most engineering joy or developer joy to write?
To be honest, every Tuesday I'm reading a Spring blog, technical blog, and I really enjoy the Spring family, and I'm a fan of everything they are providing to us. And I had been enjoying developing and trying the experimental features of the Spring Native. I really love and like to do something that could not be bring to production right now, but it could be released soon, to be on the same page with the developers of different frameworks.
Okay, yeah, I see. But, for example, when I try to write Quarkus, I also noticed that, for example, Quarkus developers mode is much more convenient than Spring's dev tools. So that it makes your life a bit easier. You don't need to restart the application all the time. You're just writing, and it automatically restarted when you save the file.
To be honest, Quarkus provides so much approaches to build your applications, and in some cases it's kind of a dog's breakfast. It's painful to change something, to build a native solution or non-native solution and switch from other one to the other one. Too much for me, too much.
Okay, good. Well, what about your experience in, let's say, in the improving performance of the building of cloud native images? Because, when you have Java, you can just compile it within 2-3 minutes. But if you need to build a native image, it takes, let's say, dozens of minutes.
Yeah.
And is there any way to make it quicker?
Make it quicker?
Yeah.
Not to migrate your monolithic legacy systems into native world. Just let your microservices be truly micro. And
Okay. Yeah, now that makes sense. Then smaller images and applications will build them quicker than will compile.
Yep.
Well, we have also Roma on the call. So, Roma, what do you think? Will we have a future where all our Java applications will be built using GraalVM?
This is the future I'm really fear about or thrilled about. I cannot choose my emotion basically, because I see the trend that everything is moving to the cloud and everything is moving to build in this native style with GraalVM. But on the one hand, on the other hand, I see kind of problem about that, because we put like all the eggs in just one place, right? On GraalVM. So everything will be on GraalVM. So I heard a story about it, something like Docker, something like this, some similar. So we already had a problem and we currently passing through this problem, right? So I think it's not so like nice and shiny. That's cool. Like the technology itself is brilliant and it's cool, but I have a small fear that we would have some problems in the future. Basically, I have a question to Vadim from my side. So, me and Sasha, we had a constant argue. Of course, we like it's friendly argue. It's not like we fighting, but it's just like we argue always that I'm a fan of Spring. Like I like Spring. I think that Spring is great and it's a great framework. And regarding other frameworks, I'm a bit skeptical because like we have the leader of the market, which is Spring, obviously, and we have other competitors who had great features, which are coming, but they're coming. And Sasha always trolls me like, "Hey Roma, what about Quarkus?" So and things like that. What do you think? What is in your opinion? Like Spring
it's your old question.
Yeah, kind of. I'm a retro.
yeah. So I think that to be the engineer, you have to know different approaches. You have to bridge the gaps in different frameworks to know in which case you could bring the brilliant decision for your customer. And to be honest, this journey, this performance tests will continue. The next step, I will stress test the Micronaut, then Ktor, after that the Halidon, and I would like to take a look on all the micro frameworks and compare them and just gather the information regarding them. Because of marketing teams could say everything, that we are the cheapest in the world, we are the fastest in the world, but the words means nothing. Show me a cut.
Okay, great. I think this is the great answer, yeah.
Yeah, and by the way, we have a question. Finally, we have a question in the chat. So it's a question from Artem. Well, the question sounds like, if I understood correctly, Java JIT wasn't taken into the consideration in those performance tests, right?
May I take a look on the question?
Well, it is somewhere on the where exactly it is. It is somewhere on the. Yeah, I see.
Let me maybe try to show it.
Yeah, why not?
I'm sharing the screen. Just could I close my presentation?
Yeah, I mean, like we need
our private chat. If you may see it now here on the stream.
Okay. Oh. I'll stop sharing. Yeah. Oh, if I understand correctly, Java Jetty, which helps running an application to run using various elastic and unload and loading classes into Zoom, wasn't taken in consideration in Zeus performance tests, right? Yep. Graal VM in different cases could be used as the hotspot. Just what about Micronaut? What about Micronaut? Could you please open your question? Micronaut. I have no.
Well, it seems this question is about what about performance of the Micronaut in this context. So have you had a chance to compare not only Spring and Quarkus, but also Spring, Quarkus, and Micronaut?
I will provide you numbers and the results of this test in January, I believe, in the very beginning of January, in the next year. So.
Fair enough, I suppose. Fair enough.
Okay, I think saying that we may close the Q&A part of this talk online. So first of all, thank you very much, Vadim, for a great talk. It was just awesome. So thank you very much for opening our main day here. And Sasha, thank you very much for moderating. It was nice to having you here on the conference. So thank you very much.